Product rule. Again, this is so fundamental, so important. This comes up all the time. So if you have a function, some function times another function, the derivative, you can't just take the derivative of each individual one, not with the product rule. You have to take the derivative of the first, multiply it by the original of the second, plus vice versa. Leave the first, take the derivative of the second. One common mistake is people will do the derivative as f prime times g prime. That's it. That is not correct. That is a very common mistake people do with the product rule. That's a common mistake. Do not do that. Do not do that. That's a common mistake. Here are some examples here. F of x is equal to 8x times sine x. So you see there's two functions here. You can think about this 8x as the f and the sine x is the g. Again, these are two separate functions here because they both have the variable here. Again, common mistake. Do not just take the derivative of each. That would be wrong. F prime of x is equals to take the derivative of the 8x first. You see the f prime, 8, leave the sine x, so 8 sine x, plus f times the derivative of sine x, which is cosine x. That's it for the first one. This one here is a little more tricky. Well, it just requires more steps. 2e to the x. You can think about that as your f. And you think about the root x as your g. So what we could do here, if you're first rewrite it, we want to get rid of the radical there so we can take the derivative of it later. 2e to the x multiplied by x to the 1/2. Square root of x is x to the 1/2. Now we can apply the power rule here. G prime of x is equal to, take the derivative of the first, well, the derivative of e to the x is just e to the x. Leave the x to the 1/2 by itself there. Plus, leave the 2e to the x, multiply by the derivative of x to the 1/2. So that's, bring the 1/2 down, x to the negative 1/2 power. And now we can rewrite this as, if you really want to leave it at this step, it's honestly fine as long as you get the process, but I'd recommend you simplify up a bit. So 2e to the x times root x. See the 2 and 2 cancel out. So it's e to the x. That's e to the x over square root of x because it's x to the negative 1/2, so it's the root x on the bottom. So that's what your g prime of x here is equal to. So again, this is good practice just to get comfortable switching back and forth between the radicals and exponents because this is a skill you're going to have. So this one right here, this is an f, that's the g. So you can say h prime of x, sorry, cut off here a bit. H prime of x is equal to, find the derivative of this. I'm just show it right here and skip a step. 1 over x can be rewritten as x to the negative first. And then if we take the derivative, just say y is equal to 1 over x, y is equal to x over 1. Y prime would just be negative 1 times x to the negative 2, which is just negative 1 over x squared, which is the derivative of 1 over x here, and then the derivative of 1 is just 1. So right here, the derivative f prime is negative 1 over x squared, and then you leave the g. Running out of room here, so I'm going to just write this under, plus f multiplied by the derivative of g, 4x here. So if you simplify this out, h prime of x is equal to, let's see here, negative 1 over x squared times 2x squared. That's just negative 2 plus, and you multiply these two terms together, which is just 5 over x squared. 1 over x times 4x is 4. 1 times 4x is 4x. And then h prime of x just becomes negative 2 plus 4 is 2, plus 5 over x squared plus 4x. This one here is our final answer. I went through these pretty quickly, so if you have questions, please clarify with your teacher, and your teacher can go over this more in detail if needed. All right, last couple problems here. Pretty common questions you might see on an AP exam. The table below shows values of two differentiable functions f and g as well as their derivatives. So you see a whole lot there. And this is honestly kind of confusing, but don't overthink it. Stick with this first and then it'll make more sense later. So h of x is equal to 3f of x times g of x. Find h prime of 2. So before we can find h prime of 2, we gotta first find h prime of x. Product rule. So you can think about as 3f of x as the f, g of x as the other one. So take the derivative of f, which is just 3 f prime of x, g of x. Again, this is purposely generic. Like the other ones here, we were given actual like equations for the function, but here it's just left generically because later on we'll plug in the values from the table. So plus, leave this here this time, so 3f of x times g prime of x. This is where you plug in all these values. F prime of, well, sorry, let's first write this h prime of 2. So h prime of 2, we just plug in, well, f prime of 2. F prime of 2 is negative 2. G of 2 is negative 1. Be very careful here. It's very easy to make some mistakes. Plus 3 times f of x, or f of 2, which is 4. G prime of 2, which is 2. So this is 3 times, well, negative 2 times negative 1 is positive 2. Positive 2 times 3 is 6. 3 times 4 times 2 is 24. So our answer here is just 30. H prime of 2 is equal to 30. This next one here is a little more tricky. Well, more algebra. Find r prime of negative 5. Well, first we've got to find r prime of x. And that's equal to, so think about, this is your first function, second function, and I'll apply the power rule. It's going to be 1/2 f prime. I'm going to write f prime instead of f prime of x to save room. Leave the other function. Now add, leaving the first one there, f over 2 plus 2, multiplied by the derivative here, which is negative g prime. So now if we want to find r prime of negative 5, 1/2 times, we need to do 1/2 times f prime of negative 5. F prime of negative 5 is 4. So 1/2 times 4. 3 minus g of negative 5, which is minus negative 2, which is plus 2, plus, what's f of negative 5? 3 over 2? Times negative g prime of negative 5. G prime of negative 5 is 5, so we just gotta make that negative. And that's equal to 1/2 of 4 is just 2, times 3 plus 2 is 5. 3 over 2 plus 2 is 7 over 2, times negative 5. 2 times 5 is 10, minus 35 over 2. And that answer here would just be, let's see, this would just be negative 15 over 2. Negative 15 over 2. So if you're confused on how we did these fractions here, like the 3 half plus 2, getting 7 halves, 3 halves plus 2, we can rewrite that as 3 halves plus 4 over 2. We want to make the common denominator, so that's just 7 halves. The 10 minus 35 over 2, that is just make common denominator of 2, so put a 2 on the bottom and multiply the 10 by 2, so it's 20 over 2 minus 35 over 2. That's how I got negative 15 over 2. Again, there's a lot of algebra and things you may have forgotten or haven't necessarily learned before, so please ask your teacher for clarification and help. It's okay if these lessons take longer because these, again, set up a foundation.